Friends, my name is Sumit Mehta. So in today's lecture, we will discuss about some questions based on integration of some particular functions. Okay, so let me write down the question. The very first question is dx over x square minus 16. So students, as you can see clearly that it is a form of dx over x square minus a square. So that we have discussed in my previous lecture. Okay, and the formula for this form is somewhat related to dx over x square minus a square, where a is plus minus 4. Okay, so we can get the answer as 1 by 2a log x minus a over x plus a. Okay, so in this case, if you put the value of a equal to 4, I'll get as x minus 4 over x plus 4 plus c. So this is the integrand that we get. Okay, students, I am taking examples so that you can remember the expressions that we derive or that we did in previous classes. Okay, now let's move to another example, which is dx over x square minus 6x plus 13. Okay, so this is an example of a quadratic given in the denominator. So can we put or can we check whether, so I can write this quadratic as x minus 3 whole square plus 2 square. Okay, so now I will simply write dx over x minus 3 whole square plus 2 square. Okay, so can I put x minus 3 as t? Let x minus 3 equal to t, then dx will be dt. Okay, now I'll start from here. So dx equal to dt, so now my expression converts to dt over t square plus 2 square. So now it is very easy because it converted to dx over x square plus a square type expression, and the formula for this is, so I can write directly tan inverse t by a. So t is t by 2 plus c and t is x minus 3. So students, now I hope that you are pretty clear about how to do this, how to do such type of examples. Now let's discuss a typical one. So student, here is one more example, that is a typical one example of, like in this what we do is we take the numerator as it is and we make the denominator in the form of numerator. Okay, so I will write a times d by dx of denominator plus 5 plus b. So what we get is differentiation of this is 4x plus 6 plus b. So from here, if we equate to this, we'll get the value of a as 1 by 4 and b as half. Okay. So once we get the value of a and b, I'll put x plus 2 upon 2x square plus 6x plus 5 is equals to 1 by 4 4x plus 6 over the expression that we get here. Okay, plus half times dx, the value of b here and the value of a here. Okay, dx over, that is 2x square plus 6x plus 5. So students, I will give this expression name I1 and this is I2. So as you can see, it it is very easy to solve this expression because I'll take the denominator as t and I will differentiate it, and there is the fraction above. So for I1 I'll put 2x square plus 6x plus 5 equal to t. So what I will get is 4x plus 6 equal dx equal dt. So what I will get is 1 by 4 dt by t. So this is 1 by 4 log of t, okay, plus c 1. So this is 1 by 4 log what our t is 2x square plus 6x plus 5 plus c1. And now to solve this expression c2 I2, I need to use the other formula. I need to make it whole x square plus a square type expression in the denominator. Okay, so can I write this as dx over x square plus 3x plus 5 by 2. Okay, I divide the expression by 2. So this is x plus 3 by 2 whole square plus, and take x plus 3 by 2 as t or u now. So dx equal to du. So the expression converts to u square plus half square, half outside. Okay, now I am writing it down here because of the space crunch. So what I will get is 1 by 2 into half tan inverse u by 2. So this is 2u, okay, plus c2. So this is cancel out 1, or you can say tan inverse 2u. What our u is x plus 3 by 2. So this is 2 times x plus 3 by 2, or I can write that is tan inverse 2x plus 3. So on getting I1 and I2, I can add both these, okay, and we'll get a final answer. So I hope students now you are pretty clear about, and this is one of the most typical questions that you might get in your exam. Okay, so be prepared for that also, students. And now I hope that you can easily solve integrals of some particular functions. And in the next lecture we'll discuss about integration by partial fractions. Okay, so stay tuned for that lecture, students. Thank you. Happy learning.